Welcome to Basic Maths class 16th. So in the previous class we discussed about what about the slope of a graph and how we'll calculate the value of slope of a graph. Now we'll discuss what we can do with that slope. What are the applications of that? So one of the main application of this is to find out the maximum and the minimum value of a function. So in this class basically we'll discuss about how to find out maxima and minima. So first we'll discuss what do you mean by this maxima and what do you mean by minima of a function. As an example, if I'm writing y is equal to nothing but x plus 5 and we are allowed to put any value for x. We can put x as 0, we can put x as 2, we can put x as 3, we can put x as 100, we can put x as infinity, we can put x as minus 1 by 2, we can put x as minus infinity, we can put any value for x. Depends upon that the value of y is going to change. So what about the maximum possible value of y over here? So we can observe that if I am putting this x as nothing but infinity, then the value of y is going to be nothing but infinity. So we can say that over here the maximum possible value of y is nothing but infinity. And if we are talking about the minimum possible value, if I am putting x as minus infinity, then I'll get y as minus infinity. So the minimum possible value is nothing but minus infinity. So we can't say that it is having any specific value of maxima or specific value of minima. But instead of this, if I am writing y is equal to x square plus 5, and if you are asking what is the maximum possible value for y, so we know that if I am putting x is equal to nothing but infinity, then the maximum possible value of y is going to be nothing but infinity. But if you are talking about the minimum value for this y, so we can observe that the minimum possible value for this y is nothing but 5, and you can put any value for x, but always you will get the value of y, or the value of y cannot be less than 5. So we can say that it is having a specific minimum value, that is 5, but it is not having a specific maxima. Maxima is nothing but infinity. So like that, in a situation something like this, it is easy to find out, because we know that if I'm putting any negative value, if you are squaring it again, we'll get a positive value. So we'll get y is minimum when x is equal to 0. That's why we are getting y, the minimum possible value of y is nothing but 5. But if we are taking another example, let's say something like y is equal to x square minus 2x plus 1. And our aim is to find out what is the maximum possible value and minimum possible value of y. We are allowed to put any value for x. In this situation, we'll get the maximum value for y is equal to infinity. And if you are finding out the minimum possible value, so over here you will get the minimum value of y is equal to nothing but 0. And you can try with any values of x. We can put any value for x, but in any situation you will not get a value which is less than 0. So the minimum possible value of y over here is 0, but right now you don't know why we are getting this minimum value of 0 and how we'll find out. So in a situation something like this, we can use the concept of this slope of a graph, and we can find out what about the minimum possible value and maximum possible value. So I'll explain how I'm getting this minimum value as nothing but 0, and for what value of x we'll get the minimum value over here. So for a value of x which is equal to nothing but plus 1, we are going to get the minimum value. So we'll discuss how I'm getting this value, or how we'll be able to find out the maxima and minima of a function. So over here, consider a situation in which for a function, let's say y is equal to f of x. We just draw a graph and assume that the shape of this graph is something like this. So according to this graph, we can observe that at this particular point, we can say that the value of y is going to be a maximum value. So this is the maximum possible value of x, and the corresponding value of x, I'm just representing it as something but x. Now we can observe that this at this maxima, if I'm finding out the value of slope. So over here, if you're finding out the value of slope, we can observe that the value of this theta is less than 90. So already in the previous class we discussed that it represents that the function is an increasing function, and here the value of this slope is decreasing. And at this particular point, at maxima, we can observe that the value of this theta over here becomes equal to 0, or slope is equal to 0. And after that you can observe that the value of theta is greater than 90 degree. That means the function is going to decrease. So function is increasing, and keep on increasing up to this particular point, and this one is a point of maxima, and at maxima the value of slope becomes equal to 0, then the function is going to decrease. So we can say that at maxima the condition is that the value of slope is equal to 0, and we know that the value of slope or the value of tan theta or the value of this dy by dx, that should be equal to 0. So the condition for maxima is dy by dx is equal to 0. Almost like maxima, we'll discuss what about the condition for minima. So for a function y is equal to f of x, if you're drawing a graph, and let's say the shape of this graph is something like this. So at this particular point you can observe that the value of y is having its minimum value. So this one is representing the minimum possible value of y, and over here also if you are finding out the value of slope, we'll get the value of the slope angle as equal to 0. Or over here you can observe that the value of theta was greater than 90, that means the function is decreasing, and at this particular point function is having its minimum value, or y is having its minimum value. After that the value of theta over here becomes positive, or it is less than 90, that means function is increasing. So this one is a point where we are getting a minimum value, and the condition for minima, we can write at minima the value of its slope or the value of tan theta or the value of its dy by dx should be equal to 0. So we can observe that the condition for maxima and the condition for minima are same. Now consider a situation in which the graph is something like this. So over here you can observe that this one is a point where the value of its slope angle or the value of this theta is equal to 0, and at this particular point also slope is equal to 0, and over here also the value of slope is equal to 0, and this situation also we can say that slope is equal to 0. So at this particular location we can observe that as the value of this y is maximum compared to its neighborhood points, so this one is representing a maxima. And same as like that over here, as compared to its neighborhood values, over here and over here, this one is representing an maxima. So over here you can say that if this is representing a maxima, so we can say that this one is also representing a maxima. So over here you can say that this function is basically, or this graph is having more than one maxima. So just remember that, but you can observe that let's say this maxima in the first situation is greater than maxima in the second situation. So you should not get confused with that maxima, because the maxima from a graph is actually representing that compared to its neighborhood values we are getting a maximum values. And same thing you can observe it over here also. For this particular point the value of y is minimum as compared to its neighborhood points. So this is representing a minima. Let's say I'm just considering minima 1, and this one is also representing another minima. So over here also compared to its neighborhood values, the value of y is going to be minima. So this is also representing a minima. So a function depends upon the situation. It can have a more than one maximas and more than one minimas, and these are known as nothing but local maximas and local minima. So a function, it's maybe possible that a function is not having any maxima or minima, or a function is having one maxima and no minima, or a function is having minima and there is no maxima, or one maxima and one minima, or more than one maximas and more than one minimas. So just minima or maxima is relative with respect to neighborhood values, whether it is maxima, or with respect to neighborhood values, whether it is minima. And the condition for maxima and minima will remain same. Always at the value of slope will be equal to 0. So just remember this part. For a value of x, if y is either maximum or minimum relative to the neighborhood values, then these points are called points of maxima or minima of the function. And remember that at the point of maxima or minima, the value of slope is equal to 0, or you can write the value of dy by dx is equal to 0. Hope so that you understood what you mean by maxima and minima of a function. If you are having any doubts, or if you'd like to interact with me on live classes, or if you want to write online test for JEE Mains Advanced as well as for Neet to improve your performance, please let me know. Thank you.